need to dynamically enable or disable AI tools at runtime without restarting your entire server. You'll see how FastMCP lets you toggle tool availability programmatically, giving you fine-grained control over which capabilities are exposed to your AI models at any given moment. The pattern uses simple method calls to instantly change tool states, perfect for maintenance windows, feature rollouts, or conditional access scenarios.
At MCP, tool. Def dynamic tool. Return, I am a dynamic tool. Hash disable and re-enable the tool. Dynamic tool disable. Dynamic tool enable.
This demonstrates dynamic tool management through runtime control patterns. The code shows how tools can be programmatically enabled or disabled without modifying their implementation, treating tool availability as a runtime property rather than a compile time decision. What makes this distinctive is the separation between tool definition and tool availability, allowing systems to adapt their capabilities without code changes. The pattern works by exposing enable-disable methods on tool objects, creating a live configuration layer above the implementation. When a tool is disabled, it becomes invisible to clients and callers, effectively removing it from the system's capability set until re-enabled. This approach follows the principle of late binding, where system behavior is determined at runtime rather than being hard-coded, enabling features like feature flags, maintenance modes, or permission-based access control. This matters because it solves the problem of static tool registries that require server restarts for changes. The dynamic approach enables hot reloading of capabilities, A/B testing of tools, and graceful degradation of services. The trade-off is increased system complexity to track tool states, but for systems requiring runtime adaptability, like AI agents that need to modify their available actions based on context, this pattern provides essential flexibility without sacrificing type safety or discoverability. Let's break it down line by line.
At MCP, tool. Def dynamic tool.
The @MCP tool Decorator registers this function as an AI callable tool in FastMCP. It transforms the Python function into a tool that AI models can discover, inspect via its schema, and invoke dynamically. This is the core pattern for exposing functionality to AI agents. Type hints and doc strings automatically become the tool's interface definition.
Return, I am a dynamic tool.
This defines the tool's response payload. When the AI calls this tool, it receives this exact string, demonstrating the simplest possible tool implementation.
Hash disable and re-enable the tool. Dynamic tool disable.
This temporarily disables the tool, removing it from FastMCP's available toolset. Useful for testing or dynamically controlling tool availability without modifying the original function. The Decorator pattern ensures the underlying function remains intact while toggling its exposure.
Dynamic tool enable.
This re-enables the previously disabled tool, restoring its availability to the AI model. The enable-disable pattern provides runtime control over tool exposure without modifying the underlying function. Dynamic tool control. The enable-disable methods transform FastMCP tools into runtime configurable components, letting you modify tool availability without server restarts. Disabled tools vanish from list tools and behave as if they never existed, yet their implementation remains intact. This pattern enables feature flags, maintenance modes, and dynamic toolsets without code changes.
The tool that disappears from the list still answers when called by its true name.